Hello everyone, welcome to our pre-calculus class. This is our lesson 10, the graph of a function from section 2.2. So we have this for our agenda: identifying the graph of a function, obtaining information from the graph like domain and range, intercepts and other criteria. So if a graph is given, how do we find out this thing? We will try to find out, and then some practice math. So first of all, how do we know one graph is a function graph or not a function graph? Now, from our previous lesson, you know that if some function is given in algebraic form, then actually you understand that which one is function, which one is not. For example, let's say y equals to x squared, this one, or let's say y equals to some new function, suppose, or y square equals to x, or x y equals to plus minus, suppose plus minus root of x, this kind of thing. And you know that y equal to x square will be a function because for every x value there is only one answer. Suppose if x equals to x y, suppose if x equals to 1, y equals to 1. If x equals to 2, y equals to 4. So only one answer. One answer. Now here x equals to, suppose if x equals to 1, if you put 1 here, answer will be plus minus 1. Answer will be plus minus 1. Two answer here, plus 1 minus 1. If answer value is 2 here, then you will get two answer. One is root 2, that means plus root 2, or 1 point, this is 1.41, and then minus 1.41. So you get two answer here. For one input you get two output. That's why this is not a function, this is a function. Normally, if you look at any given algebraic form, then if you see somewhere y square, we can actually say that this is not going to be a function, because y square graph is going to give this kind of scenario, plus minus of something. When you transfer the square from this side to that side, it will give us plus minus, which means that for each x value, this is going to give us 2y value. Okay, so that's a way to understand like which function, given function. These are equation actually. This which given equation is like showing us as a function or not. If we write fx equals to, let's say fx equals to, then it's a function. So let's write fx equals to, which is better. So now we can say that this one is function, this one is not a function. Why? The reason is same, because here each x value has one value, one y value, and here it is not a function because one x value has two different y value. That's why. So now the point is, if the graph is given, how do we know? There is a very easy and very straightforward answer for that. This is called vertical line test, and that is, let me show you here. That is, on the graph you will draw a vertical line. On the graph you will draw a vertical line. If your line intersects the graph at, there is two graph here, so we have drawn two lines. If your graph intersect the, if your line intersect the graph at two different points, so here, see here one point, here another point, 2 points it intersected. So this is not, if it intersects at two different points, then it is not a function graph. Two or more, then it is not a function graph. This is not a function graph. Now see this vertical line, wherever you draw here on this graph, it always intersect at only one point. Only one point. So okay, so here this is a function. At only one point it is a function. Now you can say, sir, you have drawn the line here. What about if I draw it here? You will see that if it is a function, then it will intersect the graph wherever you draw at any one point. Now one tricky thing is, like you can say, sir, if I draw a line here, then it is just only 1 point. What about that? Actually, we need to move it around. If we see anywhere on the graph, the vertical line intersect 2 points or more than 2, then it is not a function. So it is not a function. It is a function. Okay, this is called vertical line. These are the vertical line. You draw a vertical line on the graph. If the vertical line passes through 1 point, then it is a function. If the vertical line passes through 2 or more points, then it is not a function. These are the, like the previous thing, kind of x values are the input, y values are the output. Vertical line means x equals to 2, x equals to 3, x equal to something means vertical line. X equals to something means vertical line. We have more problems. If you want to practice this kind of math actually we'll practice these maths during our class time. We'll practice maths from there. Finding the domain and range from a graph. So this is another very important thing, and probably one of the most important thing that you will see in pre-calculus class, and one of the thing that will make huge difference during the process of this entire pre-calculus thing. This is finding the domain and range. Very important. So what is the domain? Domain means all x values, all the valid x values is domain, range is y values. Very simple thing. Now what is the domain and range of this given graphs? Suppose a graph is given here. What is the domain and range? So domain means for the given graph, what is the values of x here? X is from where to where? Y, that is the domain. Y is from where to where in the graph, that is the range. Now look, this, if you look at this graph, x value will be from here, x is from here to here. This is the x value. So from -3 to +3 is the domain of this graph. Of course not included because it is whole. See the difference. This is a block, this is a whole. So this is in the domain. From the domain of this, we cannot include the exact -3, but after -3 it will start, and before -3 it will stop. Whole means that. Whole means that. Thus, in simple words, whole means we cannot include the exact point. We cannot include the point. And dark means we have to include the point. In other words, dark means you have to give the third bracket or greater or equal to, and in the this whole means we have to give the first bracket or just only less or equal to sign. This dark means we have to give, I mean, based on the situation, okay, which symbol it will go, it will depend on the situation, but whole means this equal to sign will come, and this dark means this equal to sign will come, and whole means just only greater or less. That's it. Anyway, let's come back to the point. So the domain of this function will be from -3 to +3. So it will be from -3 to +3. This is the domain, x value. Now the range. So the range will be from, see, the y value is the range. So y value is from, this is -4, this is -1. So range is from -4, then up to -4 to 1, -4 to -1. And now see, this is a little bit annoying. It may feel, because this symbol is actually, it looks like it is connected, because now whole is not given here, so we have to connect it. We have to take this point, so we can write it this way. We can write it this way, and here is it. So domain for different functions is like this. So this one we solved. Domain is -3, from -3 to x to 3, and the range is from -4 to y to -1, and -1 is included. Okay, -1 is included. And look at the other graphs. If it's not making sense, see, this domain is from here to here, so x value is from -4 to 0, and the range is from +4 to 0. Range is from +4 to 0, and this is written here. And for this function, Domain is from +1 to +infinity since it is going forever, and range is from +2 to +infinity, going up also forever, which means x is greater or equal to greater or equals to 1, greater or equals to 1, which means from here to this side. This is the starting on the x line. So from here to this way, these are the domain side, and you can see that if you go, the graph is actually going this direction somewhat. This is how we know that the graph will go to the infinity. That's why we are saying all the x values greater or equal to 1. And for range, as you can see, graph is actually going somewhat up in this direction also. So you see, graph started at 2 in the y direction. Graph started at 2 and going to the infinity. That's why y is greater or equals to 2. Yeah. So this is how we can identify the domain and range from the graph. Look at this picture again and again. And if any of them is not making sense to you, please ask me during the class, okay? Ask me. So there are a couple of graphs and think about it. What will be the domain and graph of this function? So the function is this and this is the equation, and the graph is this. This is the equation and graph. From the graph, now think about what will be the domain and range from this graph, and write it in the note in your copy. Then I will show you the answer if it makes sense or not. There are some arrow sign everywhere. There is some arrow sign. Consider arrow sign. Because it is open function. There is no restriction here. Then pause the video, then when unpause whenever you are finished with these answers. Look at the graph and try to find out domain and range. Then I will show you the answer so that you can match your answer and our answers. So for these functions, domain is, as you can see, all real number. It will go forever in the both direction. But there is no graph in the downside. That's why range is y is greater or equal to 0. The graph goes through this. Here domain is all real number, range is also all real number, because the graph will go forever in the both x and y direction. Here the domain is from 0 to +infinity, range is also from 0 to +infinity. X is greater or equals to 0 means that, y is greater or equals to means that, 0 to +infinity. Okay. Here domain is all real number other than 0, because for 0 the function is not defined, or you can see it. The graph is coming closer and closer to the x line, y line here, and x line here. Okay, but it will not touch the exact line. So this is how we understand their domain and range. Finding other informations from the graph. So if a graph is given, basically we can try to find out many other information. So suppose we can think about what is the value of f what is the value of f of -1. F of -1 means if x equals to -1, what is the value of y? So -1 is here. If x equals to -1, the value of y is here, somewhat at -1 to 3, -3. So what f of -1 means answer is equals to -3. So basically here the x value is written and answer is the y value. Very important thing. Answer is the y value, and when you write f of x, this is the x value. Inside the bracket it is x value. And f of 2 equals to what? So 1, 2. So 2 is here. 2 is here. Then f of 2 means answer is what? Here. So 1, 2, 3, 4. That means 4. So f of 2 means 4. F of 2 means 4. So inside this is x, and equal to means this is y value from the graph. Now see, f of, now they are asking x equal to what if y equal to 3. So see, y equal to 3, 1, 2, 3. Y equal to 3 is here. But this is interesting. From this graph, y equal to 3 is where? 1, 2, 3. Y equal to 3 is here. But you see, if you draw a line here, you get actually a couple of points for our x. So let me write it for very clear answer. So you see, x value, we have couple of x value for y equal to 3. What? Because this point also y equal to 3, this point also y equal to 3, this point also y equal to 3, and graph is going in this direction, so we can actually consider this point also y equals to 3 from this graph. We have more another example in the next slide, so you will see that. So here y equals to 3 means this is minus 1, minus 2, minus 3, minus 4. So at minus 4, this is y equal to 3. Then at some point like 1 point something, y equals to 3. Then 2 point something here, y equals to 3. Then maybe this is 1, 2, 3, 4, 5, 6, 7. Then at 7 also y equals to 3. Now, yeah, there are many points where you have y equals to 3. If x equals to means, if x equals to 3 means y equal to 3, now x equals to what? Find it out. That kind of question. Yeah. Suppose here if x equals to 2, that means you write y equals to 2 is where you write a line there and find out where you have what is the x value there. What is the x value there? Just simply this value is given the x value, then you have to find out, okay, if x equals to 2, if x equals to 2, then we have to find out the y value of that line. Let's say if x equals to 2 is 1, 2 here, then you go, okay, this is the if x equals to 2 line. This is the x equals to 2 line. X value is 2 here on this line. On this line, x value is 2 everywhere, and y value is we have our graph here, so we can find out the y value from the graph. So this way we can actually do this calculation. In the next page we have another example, more clearer example here, because here the points are also given. Okay, the value of the points are given. So first question is find f of 0, f of minus 6. It means if x equals to 0, what is the value of y? So you see, if x equals to 0, x equals to 0 is here. Y value is what? It is actually written here. If x equals to 0, this is x equals to 0, y equals to what? Y equals to 3. That's why this is the answer. If x equals to minus 6, this is C, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 here, then y equals to minus 3. If x equals to minus 6, x value is minus 6, then y equals to minus 3. So when the value are given, this is easier for you all to find it out. Of course, for us also, we can just look and tell the answer. If the points are not given, then actually we draw it and then try to find the answers. Then f of 6 equals to 0. F of 6 means x value is 6, then y value is 0. You go, see, x value is 6. This is the x value 6, y value is 0 here. This way we can actually look at this, all of them. What are the x-intercepts? So x-intercepts is here, here, here. They are the x-intercept. How do we know? Because our y value is 0. If y value is 0, they are the x-intercept. And if x value is 0, they are the y-intercept. Okay. Now, from 14 and 11, we have to find out the domain and range. So domain is the x value, range is the y value, intercept is this one, and this one for x, and only 0 for the y value. And this is not a function. See, we said that vertical line test, you have to draw a vertical line. If the graph touch at 2 different points, then it is not a function. That's why it is not a function. It is a function. See, graph only touch at only 1 point. Wherever you draw the line, graph only touch at only graph cuts. The line cuts the graph at only 1 point. That's why. This math is this is 9 number math, but 10 number math of this same 10 number math is also same from section 2.2, and this kind of more maths you will have in the page number 65, and of course we will practice these maths and this maths during our class time. This kind of maths. This is the number like 10 number, and more practice maths from here. So 9, 10 they are the similar math. 11, 14 they are 11, 14 number is from the graph, finding functions, not functions, then another information. 39 number is real life math, etc., etc. And so thank you all. Thank you very much. I think that's the end of this slides. So see you all during the class. Bye bye.